guys, so in this lecture we are going to be looking at the physics practical solutions. We already did our practicals. Now some of you might have not done these practicals, and it will not be okay if you just copy values from here to do your manual. Is that okay? So you must go to the practical, ensure you follow the procedures. And another thing that you should also need to know is that you are not here to just copy values from here. You use your own value from your practical. The essence of this lecture is for you to know the procedures that actually you should follow in order for you to get a very neat graph and very accurate results, and also to ensure that you don't cancel your manual anyhow. Is that okay? So the first practical is the practical that is used to confirm Snell's law using the glass block. Now we already have our values. This is L1. We already have our table of values. You have your angle theta, and then you have the various measurement for the angle. Of course, we start with 70 degree. Then we have 60 degree. We have 50. We have 40, and of course we have 30. And then cos theta was not given to you, but it's part of the table, so you have to look for cos theta. You measured NZ and ROZ, but this column here was not given to you, so you have to work on that column. Is that okay? Now for cos theta, all you need to do is to press the cos of theta, cos of each of these angles you have here. So you press cos 70, press cos 60, press cos 50, you press cos 40, press cos 30, and it's going to give you this value, this value, this value, this value, and this value. Now your NZ and your ROZ is something that you already measured. Now there's something I want you to know, is more like a check before you continue solving, and that check is that you want to check for the refractive index using the table you have here. Now you have the graph. They say plot a graph of cos theta against x. Now it means cos theta will be on top and x will be under. And if you find the slope of this graph, you can find the slope by using any two values. Use these two values here, and then correspondingly you are going to use these two values here, because your slope is supposed to give you the refractive index of glass, and the refractive index of glass is measured around 1.60. So if you get, let's say 1.4, you are correct. 1.5, you are correct. 1.7, you are correct. Let's take it a little bit 1.8, but anything that falls outside of this range, you might, I'm afraid you might, but report it the way it is. Is that okay? Report it the way you have it in your manual. But anything outside this range here, I'm afraid your values might be having some errors. Some persons I get 1.2, 1. Is also okay, but the correct values are supposed to fall within this range, which are the refractive index of the glass prism. Is that okay? Now, how do you know if your values are correct? You take the two last values, first and last value of cos theta, subtract them. So this will be 0.8660 minus 0.3420 divided by 0.5600 minus 0.2615. Now when you subtract this, if you press this in your calculator and then do the arithmetic, let's see what you're going to get. 0.8660 minus 0.3420 divided by 0.506 minus 0.2615. Now my dear student, what did you get? You got 1.75. So it's within the range, which is very correct. 1.755 is within the range, which is very, very correct. So we can decide to use these values to plot our graph and then get our answer. Is that okay? So we want to plot a graph of cos theta against NZ. Is that okay? We want to plot a graph of cos theta against NZ. So what we are going to do now is to take this table to our graph sheet and then plot and see what we are going to get. Is that okay? So let's go to our graph sheet. Alright, so we are going to plot a graph of cos theta on the y-axis, and then x, which is equivalent to nz all over roz on the x-axis. Now note something. This x, you got it by dividing nz all over roz, which is part of the values you get from your practical. So each of the nz value, you divide them by the roz value on the same row. So how do we now plot our graph? Of course, you all should have known how to plot graph by now. Let me see if this pen will work. Okay, let's use blue to draw our line first, and then draw this line that comes this way. Good. Now that you've drawn this line, let's take our scale. What do you think our scale will be for this particular practical? You can decide to say, let's look at the values you have on cos theta. 0.3, 0.5, 0.6, 0.7, 0.8. Okay, we can say okay, the pen is too big. We can say let 0.1, or let 1 centimeter, or you can use 2 centimeter. Let me see how many pages are in your graph, how many of those spaces are in your graph now, so that we use that one to take the slope. If we take 0.2, this will be 1, 2, 3, 4, 5, 6, 7, 8, 9. You can take 0.2 in your note, or you can take 2 centimeter in your note. So you can say let 2 centimeter be 0.1 unit on y-axis, and then when you now come to x-axis, you can also say let 2 centimeter be 0.1 unit on x-axis. Now, what is the title of this graph? What do you think is the title of this graph? Now, this graph is a graph. First of all, write the title. A graph of cos theta against x. A graph of cos theta against x. Now that you've written your title and your scale, you are now going to come down here and write under here 0, 0. Now, this second semester physics practical is very, very simple, just for you to understand what you are doing, and then you are good to go. So we say let 2 centimeter be 0.1 unit. So every 2 centimeter you see here will be 0.1 unit. So this is 1 centimeter, let's assume. So here will be 2 centimeter. So here will be 0.1. Here will be 0.2, 0.3. Mine might not be up to 0.4, 0.5, 0.6, 0.7. Okay, we have to scale it up. 0.7. Let me move this one from here. Up we go, and then we'll move this one a little upward. So that's 0.7. Here will be 0.8. Here will be 0.9. Think is good like this. And then you also come here. Here will be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and here is what? 0.7. I think the highest value there is around, the highest value here is around 0.56. So for cos theta, we start plotting. When cos theta was 0.34, let's take 0.34, very close to 0.5, 0.35 rather. Our x is 0.26. So we have this one as 0.3. 0.35 will be somewhere around here. So 0.34 will fall a little bit below this. This other one, x value is 0.26. 0.26 is a little bit above 0.2. So you take this 0.2, 0.25, 0.26 will fall somewhere around here. So that point will be somewhere around here. Of course, if you have your graph sheet, you should know how to calculate, how to mark points. Then the other one is 0.5, and then this one is 0.37. So we have 0.5 on cos theta, then you have 0.3. Here is 0.3. Here is 0.35. 0.37 will be somehow close to this line here. Then you have 0.64 and 0.47. So this is 0.6. 0.64 will be somewhere around here. The 0.47 will be very close to 0.5. So 0.47 will be somewhere around here. Let's take it here. Alright. And then you have 0.76 and 0.52. So let's take 0.76. This is 0.7. Z is 0.75. 0.76 will be a little bit above 0.75. And then you have 0.52. I can't see 0.52, but I know this is 0.7. 0.76 will be a little bit above here. Then let me just mark this point and then trace 0.52 is just above, just a little bit above this line. So of course, you know, this point has fallen off of the radar, this particular point here, because it's somewhere, this is 0.5, then you have 0.52 somewhere around here. So this point is totally out. All right, this is 0.7, even 0.76 somewhere around here. All right, so this point is out, as you can see. And then you have 0.8 and then 0.56. 0.8660. This is 0.8. 0.8660 will be somewhere around here, and then 0.56. If this is 0.5, 0.56 will be a little bit above 0.5. 0.86 somewhere around here. Here is 0.5. 0.56 will be somewhere around here. You know, we are not taking it to scale because of the nature of our this thing. So it will be somewhere around here, 0.86. So at this point in time, we can now draw 0.52 will be somewhere around here. I'm now seeing a different line entirely. We can now draw a straight line through that point. All right, so the straight line will go from here. Let me just draw. This one does start. Okay, let me use this. Okay, I think this one like this is very, very perfect and very, very okay. All right, but I don't like this color of pen, so I think we'll, okay, is there any need? It's still visible. Let me just trace this one downward, take it downward, and then this one also. Now it's supposed to pass through the origin, but it didn't pass through the origin, so we just take it at this point. I think this point is so okay like this. It's very, very okay, because as it is now, it's more like it's only one point that did not fall into the, I mean, one almost fell in, then one did not fall at all into the line. This is what we should be expecting, something like this. All right, so this is our graph. Is that okay? Now the graph cannot be in just, I'm trying to zoom it. It's impossible for us to see the graph just in one sheet, but you can see how it is. All right, so this is our graph, this is our title, and then at this point now we cannot take our slope, because what we are interested in is the slope. Now when you are drawing your slope, I believe you've been told that when you want to draw your slope, you should draw it from you don't use this arrow line to draw slope. You should draw a very big slope. Don't go and draw small slope. Is that okay? This one no dey gree clean. All right, so we'll have something like this, which will run from somewhere here and then to somewhere here. All right, so this is our slope, and you see the values for the slope. I believe you know how to trace it down. 0.8660, which is somewhere around here. So you trace it to this point. Are you getting it? And then also this one, 0.34 something. You also trace it down to this point, and then you trace the other side down with their corresponding y values. So you're going to trace this one down. Sorry about the, it cannot be that accurate, but I'm supposed to be more accurate than you guys because I'm using the computer to plot. And then just that we don't have the exact graph sheet, there's 0.2 something. So this is how you draw your graph to show the various values. All right, now at this point in time, you can now take your slope. Now you are not supposed to write your slope on the graph but if you can see the slope here, you are not supposed to write it on the graph note. The slope is changing y all over changing s. So your slope will be changing y is y2 minus y1. Changing s is s2 minus s1. So my dear students, your slope would be equal to y2 is 0.8660 minus y1 is 0.34 something, 0.34, I guess, 0.3420, yeah, divided by, if you trace this value correspondingly down on the x-axis, is going to give you 0.56 and 0.215. You guys should know how to take slope by now. 0.560 minus 0.2615, something like that. Oh, sorry about that. Sorry about this one. Okay, let me just, all right, 0.2615. So we have it as 0.26 15. Now when you compute this, your slope would be equal to, press the slope in your calculator, 0.8660 minus 0.342. What would that give to us first? 0.524 divided by 0.560 minus 0.2615, 0.2985, 0.299 approximately. So when you now 0.524 divided by 0.299 give us 1.752. 1.75 is okay. So this is our slope, and this also gives us information about the refractive index of the compound, or I say of the compound, chemistry, of the glass, the refractive index of the glass, which is 1.75. Is that okay? Exactly. So we take our slope as 1.75, come back here and then do your other calculations. All right, so our slope is from the one we just calculated. The slope, very simple, is 1.75. all right, let us now answer the rest question that follow. We've plot a graph of cos theta on the y-axis against x on the horizontal axis. Now the next one is find the slope of the graph and comment on the parameter that the slope represents. Now we found the slope of the graph. We said the slope, we've calculated it. Of course, you know that slope calculation must be on your worksheet, right? The slope is 1.75. Now you can now write that the slope represents the refractive index of the glass, refractive index of the glass, which is equals to the sine of the incident angle all over the sine of the refracted angle. That is what the slope represents. Now the slope represents on the refractive index. Now you are not going to go and browse about just little details about refractive index and then write it. Just ChatGPT, what is refractive index? ChatGPT will give you a very good answer as to what refractive index is. Is that okay? Refractive index of a glass. So that everybody will not write the same thing. That's the reason why I not give you what the refractive index. But what I'm trying to tell you is that the slope represents the refractive index. Is that okay? The slope represents the refractive index. So browse what the refractive index of glass is. The expected values that you should be expecting, like the values I told you, normal glass is around 1.60, but if you now got a value 1.75, it's still within that range because of experimental errors. You just write all those things and then pad it up to give you a very voluminous discussion on the parameter that the slope represents. Told you that the slope represents the refractive index. So we can just come here now. ChatGPT should tell us what refractive index is. Let's check ChatGPT. I know it's open already. All right, so just check refractive index so that we'll know. Now, the refractive index is a fundamental optical property that describes. This is the only thing you should write, but don't write everything here. Just write the definition and then the formula. The refractive index is fundamental optical property that describes how light propagates through a medium. It is defined as the ratio of the speed of light in vacuum to the speed of light in a given material. The refractive index is denoted by the symbol n. The formula of the refractive index is n is equals to c over v, where n is the refractive index, c is the speed of light in vacuum, and v is the speed of light in the material. The refractive index is a dimensionless quantity and is always greater than or equal to 1. A refractive index of 1 implies that light travels at the same speed as it does in the media. So all these ones, they are just some other things that you can write to make up your work, but it's not really necessary. All right. Now, state 2 precautions taken while performing this experiment. I believe this experiment you used pin. You should ensure it was ensured that the pins are aligned with each other before taking measurement. It was ensured that the pins aligned with each other. When I mean aligned, I mean aligned with each other while taking measurement, because I know this experiment you are going to align some pins before you take your measurement. So it was ensured that the pin aligned with each other before taking measurement. Now another precaution is that the glass slab, the glass slab, rectangular glass slab, was held in place during measurement. The glass slab was held in place during measurement. Then zero error of meter rule was what? Avoided. Zero error of meter rule was what? Also avoided. So these are some of the precautions that we are taking while taking the experiment, and it was also ensured that there was enough light. Are you getting it? There was enough light. The place was not dark, so that accurate measurements can be taken. So these are some of the precautions. I believe that is all for your L1 practical. We'll see you in the next one. Thank you very much for your time.